Okay, let's look at another example. Example 2. Solve 2 sine of theta plus root 3 equals 0. Okay, so again, my goal is get the sine of theta by itself. Okay, you can see right away root 3, 2, you can see where this is going. This is going to look like a nice number that I can solve. Okay, so 2 sine theta is going to be 2 sine theta equals minus root 3. And then sine of theta is going to be minus root 3 over 2. So this statement is equivalent to this. I just need to now find the angles where this is true. Okay. Now I didn't say this before, but I'm going to restrict my domain, to theta is between 2 pi and 0. Okay. So this is my domain. I'm only interested in the angles from 0 to pi to 2 pi. Okay, where this is true. So where is the sine of theta equal to minus root 3 over 2? Well, there's two places where this is ASTC, right? So this is positive, so it can't be in these two quadrants. So it's got to be down in the bottom quadrant. Okay, and what angle would this be? Well, the reference angle here, sine of theta is positive root 3 over 2 at 60 degrees, or at pi over 3, right? So you can automatically think, well, that's got to be pi over 3. Okay, if that's pi over 3 and that's pi over 3, well, this angle then must be pi plus pi over 3, so that would be 3 pi over 3 plus pi over 3, so that would be at the angle 4 pi over 3. If I add one more pi over 3 here, that would be 5 pi over 3. So those are going to be my two angles there that will make this statement true, right? So theta must be equal to 4 pi over 3 and 5 pi over 3. Okay, so this would be my answer. And we have to check to make sure that it's within our original range, our domain, right? This is bigger than 0 and less than 2 pi, both of these answers. So this is correct. All right, let's try another example. And this one's going to be a little bit harder. Okay, let's try another example here. This is going to be example 3. And this one will be a little bit different. It says solve sine of 2 theta equal to 1/2. Okay, so we did sine of theta is 1/2, but now we have a sine of 2 theta equal to 1/2, and we have to solve this where theta is going to be between 2 pi and again between 2 pi and 0, where 0 is included. Alright, so there's a couple ways to do this. The way your textbook likes to do this is they want you to find the general formula. Okay, your textbook asks you to find the general formula, and then once you find the general formula, plug in values of k. So I'll just show you the way that I'll show you method 1. This is the way that your textbook does it. Okay, and you can choose to do whichever method you want. I'll start with the textbook's method. What they do is they say, well, since sine of 2 theta equals 1/2, that angle must be pi over 6 or 5 pi over 6, right? Since I know that the sine of a 1/2, right, it's going to be when I have pi over 6, that's going to be 1/2 at pi over 6 and 5 pi over 6. Okay, so this angle in here has to be 2 theta must be equal to pi over 6, or 2 theta must be equal to 5 pi over 6. And that's true, right? But the period, here's where it gets a little bit interesting. The period of this sine of 2 theta is now what? Now the period is instead of 2 pi, it's going to be pi. It's going to be pi over. Let's see. The period is going to be pi, right? The period is pi. Why? Because 2 pi over b. Okay, my omega here is b, or is 2, right? That's omega. Okay, so the period ends up being 2 pi over 2, which is just pi. All right. So what you can do here is this would be pi over 6 plus 2 pi k. Okay, so they like to do the whole making your general formula first and then checking your values of k. So if this is true, then theta is going to be equal to, if I multiply everything, or sorry, divide everything by 2, I would get this statement: theta equals pi over 12, right? If I multiply 2 here, or 1 over 2 times 1 over 2, 1 over 2 and 1 over 2 here, I would get plus pi over k. Okay, and here I'd get theta equals 5 pi over 12 plus pi times k. Okay, and notice that this now is pi, which is what we had over here, and that makes sense. Okay, so the period that it's repeating every pi, so this would be my general formula for these two situations. Alright, and I'm still looking at theta between 0 and 2 pi, so I'm still interested in finding what this is now from 0 to 2 pi. So what the book wants us to do is they'll say, well, let's find all of the values of k that will make, since this is our general form, I just need to start plugging in integers into here to see where my theta is going to be between 0 and 2 pi. Okay, so let's go ahead and do that. Pi over 12 plus pi times k, and let's have pi equals 5 pi over 12 plus pi k. And I'm just going to start plugging in values here. Let's try -1, or let's just try 0, 1, and 2, and so on. Okay. Well, theta's at 0, it's going to be pi over 12 plus 0. Okay, when k is 0. If k is 1, that's just going to be pi over 12. If k is 1, that's going to be pi over 12 plus pi. If I multiply that times 12 over 12, I get 13 pi over 12, right? So here I have two answers here. If I were to go even one step further and add a k equals 2, you can see I would get pi over 12 plus, now I would have 2 times pi, so I'd have 2 pi. To convert that to 12s, okay, I would have 24, so that would be 25 pi over 12. Now obviously here this is bigger than 2 pi, right? That's 24 pi over 12 would be 2 pi. So since that's bigger, that's not going to be an answer. Okay, so that's an answer and that's an answer. Now let's check over here. When k is 0, theta is going to be 5 pi over 12. Okay, so that's going to be 5 pi over 12. At k equals 1, that's going to be 5 pi over 12 plus pi. If I convert that to 12, denominator of 12, that would be 12 plus 5, so that would be 17 pi over 12. And that is also still less than 24. So I have 4 answers so far. Let's try k equals 2. Okay. You'll see here 2 pi times 12 over 12 is going to give me 24 plus 5, which is 29 pi over 12. And that again is too big. That's outside my my domain was 0 to 2 pi, right? Okay, and that's outside of this, so that won't be an answer. So I have 1, 2, 3, 4 places where it's going to hit. My solutions in total are going to be pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Okay, so I have 4 answers here. And let's see if that makes sense. Let's see. Does that make sense with what we had up here? Okay. Yes, it does. If I were to graph this graph, if I were to graph sine of 2 theta, I would, let's go ahead and graph that. Sine of 2 theta, where is that going to be equal to 1/2? Here's another way you can verify it. Okay, sine of 2 theta, well, that's going to repeat. That's going to be just the regular sine graph from 1 to -1, right? And that's going to be repeating from 0 to pi. Okay, I want it to be 2 pi. I want to find all the times that it hits from 0 to 2 pi where it's going to be equal to 1/2. I want to find where the sine graph is going to hit that line. Okay, but because my period has been changed to pi, really it's going to be going up from here to here. So it's going to do something like this. There's one revolution, and then it's going to come back and come back to that. So really you can see right away I have 1, 2, 3, and 4 places where it hits. So I should have 4 solutions. Okay, since this is the range that I'm interested in, right? From here to here, from 0 to 2 pi. Okay, so it makes sense to have these 4 numbers here. All right. So anytime you see this, don't be afraid. Don't get lost here, and just replace that with another variable there. Okay. All right. So that's the textbook method. Okay, and in the next video I'll show you how to do the another quicker method.